All right, example 3, we want to determine the slope of the tangent line, not necessarily the full equation of the tangent line, just the slope, to the curve of this at that point, 1, 1. So, again, we can go ahead and just take the equation and take the derivative of each side. Just copy that over there and go ahead and move it. All right, so the left-hand side, this is chain rule because we have the inside function, x minus y, and the outside function is e to the x. So chain rule, the derivative of the outside, so e to the x stays e to the x, leave the inside alone, multiply by the derivative of the inside. So multiply by the derivative of x minus y. So derivative of x is 1 minus the derivative of y, which is 1 dy dx. And since it's just 1 dy dx, we don't actually need to explicitly write that 1. Right-hand side, business as usual. This is 4x. Business as usual for the first term. 4x minus, this would be 2y. So power rule is normal, but then because we have a y term, but we're differentiating with an x term, we have to tack on the derivative there, dy dx, how y depends on x. So now this term here, we could certainly use the shortcut here. But what I'm going to do is I'm actually going to solve for this one first, just because you should know how to do this. You will see questions like this. Also, sometimes this particular type of situation, this algebraic scenario right here, sometimes trips people up. They see that there's a dy dx inside, so they know that this dy dx has to be paired with this dy dx. They have to be on the same side. But what ends up happening is in some cases, some students just leave this entire thing on this side, which is difficult because if we were to move this term to this side, we couldn't factor the dy dx out because while there is a dy dx right here, it's not multiplying this whole term. It's embedded within this term. So I can't take it out because if I were to take it out, that means this dy dx is in common with this term as well, and it's not. So what you should do here is actually distribute this e to the x minus y through. And then you've sort of like freed all the terms. You can think of these two terms being locked away by this. If you distribute, you sort of unlock, you tear down these parenthetical walls, and then you are free to move things around. So in this case, we can subtract the lone e to the x minus y to the right-hand side, and we can add the 2y dy dx to the left-hand side. And then, of course, it's in common now, the dy dx on the left, so we can factor it out. And then, of course, we can go ahead and divide to solve for dy dx. Again, we could have used the shortcut. I simply did not in this video because I wanted to illustrate and explain this little point. How do we get to this dy dx? You want to distribute to unlock all the terms and make them freely movable. All right. Once we're here, of course, we can just evaluate the derivative dy dx at our given point 1, 1. In which case, here, I'll just write this down here for a second. Right in here, I'll write this and I'll move it. We're going to have 4 minus e to the 0 all over 2 minus e to the 0, which is just 4 seconds, which is 2. Actually, my apologies. E to the 0 is what? E to the 0 is 1. So actually, we have 4 minus 1 is 3 all over 2 minus 1. So ultimately this whole thing simplifies into 3. All right, so the slope of the tangent line is 3.